874 words, within the 900 plus or minus 5% target. Here's the script. Right now, PSO J318.5-22 is still drifting through interstellar space, completely alone, and astronomers at Caltech have no way to track exactly where it's going next. No sun, no star to orbit, just a 6-Jupiter-mass planet wandering the void in total darkness. And what they found when they finally spotted it is the part they still can't explain. PSO J318.5-22 was discovered in 2013, roughly 80 light-years from Earth. It doesn't orbit anything. No star warms it. No solar system claims it. It's what scientists call a rogue planet, a world violently ejected from its birth system, now floating free through the galaxy forever. Researchers only found it by accident, scanning the sky for faint failed stars called brown dwarfs. Instead, they caught a whisper of infrared heat where nothing should have been. A planet, alone, nicknamed the loneliest planet in the galaxy by the team that found it. But the more they studied it, the less sense it made. Because something this size, this young, shouldn't be this hard to see. And it shouldn't be moving the way it's moving. Here's the anomaly. PSO J318.5-22 glows faintly in infrared from leftover heat of its own formation, a slow radioactive afterglow from being born. That's normal for a young planet. What's not normal is its light curve. It flickers, brightens, dims. Over and over, in patterns that don't match any known weather system. Astronomers have watched gas giants in our own solar system for decades. Jupiter's storms are predictable. Saturn's bands are stable, tracked for centuries. This thing is different. Its atmosphere churns in violent, shifting cloud formations that reorganize themselves every few hours, visible only because there's no starlight around it to wash out the signal. For once, the darkness itself is the reason we can see the chaos underneath. And what's underneath is not calm. The obvious explanation was simple: turbulent clouds, maybe iron and silicate rain, the kind of exotic weather predicted for young free-floating worlds. Case closed, they thought, except the models don't hold up. When researchers ran simulations matching PSO J318.5-22's composition and age, the predicted brightness swings were nowhere near what they actually observed. The real fluctuations were bigger, faster, almost 3 times more extreme than any atmospheric model could produce. Caltech researchers admitted on record that the variability exceeds what current cloud models can explain. That's scientist language for, we don't know what's happening on this planet. And there's no star nearby to help triangulate its exact path, which means the thing they can't explain is also a thing they can't precisely track. Here's the part that should worry you more. Because it isn't gravitationally bound to anything, PSO J318.5-22 isn't following a predictable orbit around a star like every planet we've ever mapped. It's moving through the galaxy on its own trajectory, shaped only by the violent birth event that flung it out millions of years ago. Astronomers can estimate its general path. They cannot pin down its exact course, its exact speed, or where it will be in 10,000 years. And here's the strange part: it shouldn't be alone at all. Rogue planets were once thought to be rare, statistical flukes, cosmic accidents. But newer microlensing surveys, ones that watch for a rogue planet's gravity briefly bending the light of a background star, suggest there could be billions of them drifting through the Milky Way alone. Dark, cold, completely undetectable unless they happen to pass in front of a distant star for a few fleeting hours. PSO J318.5-22 is one of the only ones we've ever actually seen and studied up close. Which means for every rogue planet we've caught, there could be thousands more out there right now, silent, unlit, unmapped close enough to matter, and we would never know until it was almost too late. This breaks something fundamental about how we think about safety in space. We map comets, we track asteroids. NASA runs entire programs dedicated to spotting anything that could threaten Earth from within our own solar system. But a planet with no light of its own, moving through interstellar space with no star to give away its position, that's a blind spot in the entire system. Not a small one, a structural one. If a Jupiter-sized rogue world drifted through our solar system's outer edge, it could destabilize the orbits of Neptune and Uranus, even send a cascade of comets from the Oort cloud hurtling inward toward us. And we might only detect it once it was already close enough for the damage to begin. PSO J318.5-22 isn't a threat today, but it proves the threat exists silently, and that we currently have almost no way to see it coming until it's already here. So the question nobody at Caltech wants to answer directly is this: if one lonely, wandering planet can hide in plain sight for the entire history of human astronomy, drifting undetected for millions of years, how many more are already closer than we think? And what happens the day we finally see one, not 80 light years away, but inside our own front yard? Tell us what you think is really out there in the comments.